After the calamities of plagues and invasions that left civilization crumbling in the Middle Ages, we see trade slowly start to come back. As people were no longer afraid of catching the Black Plague, they could go out and try to get things they couldn't grow for themselves. We saw the ultimate fruition of that when we looked at the exploration of the Americas. Now, all of this trade put Europeans in contact with the Muslim world. And it was in the Muslim world that had preserved the learning of Aristotle and had created many of the things that will go on to become the great universities in Western Europe. And as Western Europeans are getting access to these new texts, as they're starting to translate them from Arabic and Greek into Latin, learning explodes. And this explosion of learning is known as the Enlightenment and the scientific revolution. Now, this explosion starts with science. And the first thing it starts with is a new idea of where the Earth is in the universe. Now, you see, Aristotle was the one who developed the first model of the universe, or at least the one that was the most popular. And in his model of the universe, the Earth sits at the center, surrounded by 11 perfect crystalline spheres. Each of these spheres contains elements of the heavens. And once Aristotle gets adopted by the Christians, these spheres are moved by angels. And the Earth is protected, and we can look around and see all of the spheres of the clouds, the sun, the moon, all of the stars are existing in these different spheres. Now, there's a problem with this system, as good as it is. And that problem is that it doesn't account for things like the planets that move around the sky. Now, if you can look right over here to this video on the left, you can see what it looks like when Mercury is seen moving across the sky from planet Earth. Now, you can see in that video that it looks like Mercury loops back around itself. And that was a problem, because if the world is moving in perfect spheres, how do you explain the problem of the planets? The Renaissance is making all of these new tools. One of the things that they're making are better lenses. And these lenses, better lenses mean better observations. And one of the first places these lenses are turned to is the sky. Now, round about the 1660s, a man named Nicholas Copernicus, who was Polish, publishes, a year before he dies, a revolutionary new book arguing that the sun is not at the center of the universe, but that the Earth is not at the center of the universe, but rather the sun is. And he does this using this weird little field that nobody except for like accountants really cared about, mathematics. And using mathematics, Copernicus can prove that the reason that those planets are moving weirdly around the sky is because the Earth and them are both revolving around the sun at different speeds. Now, if you look at the video here, you can see that. So you can see that two things revolving around around the same center at different speeds will lap each other. Now, Copernicus's idea is revolutionary, and it shatters the perception that people have. And his theory does two fundamental things. Number one, it argues that the universe is far bigger than we had ever imagined. Because if you think about it, if the Earth is revolving all the way around the sun every single year, and yet it doesn't look like the stars move that much at all. So that means the universe must be enormous. So he challenges two things. Number one, his calculations prove that the universe is far larger than we'd ever expected. And the other thing he does is that using this little accountancy tool of mathematics, he flips the hierarchy of knowledge. Prior to Copernicus, the smartest and the sophisticated of the sciences were theology and philosophy, pondering and using deduction to unlock the mysteries of God and the reasons why humans exist. Now, but it doesn't just stop with Copernicus. After he dies, a Dutchman named Johannes Kepler continues to work on his theories. And he takes that language of mathematics that Copernicus is using, and what Kepler does is he refines it. Kepler can place the planets in the universe precisely using the language of mathematics. And this language continues to spread. You see somebody like Galileo in Italy challenging this ancient idea that things move because a magical or an invisible force is applied to them, and that as soon as that force is removed, an object will cease to move. But using mathematics, Aristotle is able to prove the concept of inertia, that objects tend to remain in the state they are, at rest if they're at rest, or in motion if they're in motion, until some other object acts upon them. And this starts to really challenge everybody's understanding of the laws of the universe. Suddenly, the universe is mechanical. It functions just like any other machine, with these laws that make all of these phenomena predictable. Galileo is going to be persecuted for these ideas, especially by the Catholic Church. He's actually put under house arrest until he dies. Robert Bellarmine has something to do with that too, mostly helping to smuggle his works out so that they will later be published. Now, in addition to, who am I thinking of after Aristotle? Oh, yeah. So, and after Aristotle, the person who's probably the most famous in all of this scientific revolution is Isaac Newton. Now, what Isaac Newton will do is he will take the ideas of mathematics and he will drive them to their greatest extreme. And he will come up with a theory that's known as the universal theory of gravitation. And it's fundamentally this, that all bodies in the universe are attracted to each other equally, depending on their size. And so the bigger objects attract smaller objects more powerfully, which is why we don't experience gravity between myself and these picnic tables I'm about to walk by, or other human beings, but I feel the gravitational pull towards the Earth. But in fact, I have my own gravitational pull as well. So these changes that are occurring because of science don't stay there. This idea that the universe follows specific rules that can be observed and understood also will get applied to human societies. People like John Locke and Thomas Hobbes start to question why kings and nobility are special or different than peasants. They'll come to this idea that we all have natural rights, that a king might be better because they have more property and more access to things, but they're not fundamentally different. And this idea of natural rights will then feed into this idea of, okay, if we're all the same and we all have certain gifts and talents and we all have some things that are just universal, then maybe our society should be arranged in a different way. And so this idea of natural rights will get picked up by people like Rousseau, who will argue for a social contract, that society should be based on a set of interlocking obligations. Those who are given power by the people that they rule are required to make lives better for the people that they rule. And if they fail to live up to their obligations, then the people who they rule don't have to agree to be ruled by them anymore. We'll see this idea first take place in the British colonies that become the United States, but it will spread across Western Europe and eventually the entire world. In addition to this idea of social contracts, other scholars will start to look at the powers of government and start to question whether or not so much power should be concentrated in the hands of an absolutist monarch. People like Montesquieu in Italy will start to argue that the powers of government should be broken up into different institutions that have to compete against each other for power. Again, we'll see this adapted into the United States Constitution with Congress being able to create laws, the president executing those laws, and a judicial system designed to interpret whether or not those laws are in fact legal and fit with a larger constitution. This time in Europe, we will see in the next few hundred years an explosion of knowledge, and human societies will change more between 1700 and 2023 than they had from 1000 to 1700. I can't wait to explore these next few hundred years with you as we begin our time in what becomes known as the modern era. I look forward to your questions and your discussions, and I hope this sets a background for your readings and your explorations in this unit.